Welcome to Happy Path Programming. I'm Bruce Eckel.
I'm James Ward.
Hey, this is James. Just a quick note. On this episode, we had a little audio issue and apologize. I think it's a really good episode, and so we didn't want to lose it, but apologize for Bruce and my bad audio. We'll do better next time. Thanks.
All right. Well, today we have with us Simon Vergauwen, which I think I butchered that Dutch last name. And I know Simon primarily from your work on the Arrow Kotlin functional programming library, and so we definitely want to talk about Arrow and get into that functional programming in general. Welcome, Simon. Good to have you with us.
Thank you, James. Thank you, Bruce. Thanks so much for having me here.
Have you. So maybe we cross paths in the Scala times too, because did you start in Scala before Kotlin? Did you ever do any Scala or just
actually not. So my background is Android and Java, but I started with Kotlin late 2015, so about 7 years ago. And at the time, there were no resources whatsoever in Kotlin. So a couple of my colleagues at the time recommended me to get into Scala and read some Scala books to learn and grow my Kotlin skills. So that is actually how I got into Scala. So probably the other way around for most people.
So you did some Scala so that you could learn Kotlin.
Yes, exactly.
Interesting path. Yeah. What about functional programming too? Were you doing any FP in Java? I guess there's some.
So ReactiveX and RxJava was very popular at the time on Android. So I think that was my first getting in touch with functional programming patterns. And then, when I was learning Scala, I very quickly got into type level, which was very popular at the time. And that's how I got in touch with functional programming. And then, I very quickly wanted to apply all these same patterns in Kotlin, and that's how it really got started.
You dove pretty deep into the deep end of functional programming in Scala pretty quickly. Right. I still look at the type level stuff, and I'm still that's too deep end-ish for me. Mm-hmm. You're like, okay, let's go all the way into the hardest hardcore stuff you can possibly do in Scala.
I mean, I tried, but it was all kind of off-putting. It was too dense, and too, I don't know how to describe it, but it also felt kind of exclusive. It felt like, especially some of the early stuff that they were coming up with the monadic libraries and stuff. It felt like it's like, no, this is a club you can't join. Yeah, there was a lot of that.
But Simon just went right in.
Yeah, I guess. I'm fine.
You must have a math background then?
No, actually, my background is in electronics. So I'm actually an electronic engineer. So completely unrelated to software. But I really enjoyed software. I did a lot of assembly back in school in C. And I really loved software because it felt that I could build anything just on my computer, compared to electronics where I have to order a bunch of components and draw diagrams, get PCBs printed in China, which take a couple of weeks to have them at home. And software, you just have everything at your fingertips on your computer.
And then in a second, you can recompile and rerun your application and see the changes, where with electronics.
Well, plus the potential of higher level languages. I came from a kind of a similar background, and it's like the low level stuff was fascinating, but hey, as long as the computer takes care of the zeros and ones, I want to be able to build higher level abstractions so that we can make things faster. Yeah.
Exactly.
So you were diving in, doing some hardcore functional programming in Scala. What was it like for you to learn functional programming, especially at that kind of depth?
So at first it felt like an endless pit of stuff. Whenever I learned something new, it felt like there were 10 other things that I didn't know. So it was a long journey, or at least it felt like that. But after a while, you start getting used to everything. You also kind of learn to let some things go. Like, okay, this is an area I don't understand yet. Maybe I'll get to it later. But yeah, working mostly in Kotlin, there was also some things that I wanted to bring to Kotlin and other things that I didn't. So I guess that was kind of my journey. And in Arrow, we made it a very long journey. Seeing what makes sense, what was important, what we felt that was not important.
So you're
but
learning all
overall,
this as a way to learn the functional programming constructs with the goal of wanting to bring those to Kotlin.
Yeah.
Is that right?
Yeah, because when I got started on a journey, I was still doing Android, and so Scala really didn't feel comfortable on Android. So Kotlin felt much better than Java. My end goal was to bring the practices that I was learning to my workplace and apply them on the projects that I was working on. So yeah, that for me was the end goal.
So you started in Scala to kind of understand all these concepts, and then, but had you already been learning Kotlin, or did you learn Scala first and then Kotlin?
No, so I started with Kotlin, like I said, late 2015, and I had never touched Scala at that point.
Okay.
But there was so little resources, and there was these foreign concepts in Kotlin, or at least foreign coming from Java, like sealed classes, these data classes, and using them efficiently. Those were all new things to me, and the only resources that I could find were in Scala. So that is how I got in touch with Scala.
Just using Scala as a way to learn the concepts of functional programming, because that didn't exist yet in the world of Kotlin.
Exactly.
But the goal was to bring that stuff, at least some of it, to the world of Kotlin.
And how was your experience in, like, when learning both of those languages? What was your perception of Scala and Kotlin?
Well,
pluses
originally they seemed very similar, and I think when you get started with the basics in Scala, a lot of the stuff overlaps. But the deeper you go into Scala, the more you learn that it's a very complex language. It can do a lot of things that Kotlin can't, and that comes with its pros and cons. For example, I think at the time in 2015, the cake pattern was still quite popular in Scala, which I thought was kind of nuts. And I'm still not sure if I really understand it.
I never really grasped it. I figured because I must not know the domain that this is being used in, but it never really made sense to me. So that's gratifying to hear that you didn't understand it.
You spent a little bit of time with the cake pattern. I think take all of us help you understand.
That's right.
But yeah, I never really connected with that particular.
I didn't understand what problem they were trying to solve, which is often the case when I don't understand something.
Baking cakes, burritos and cakes.
Burritos and cakes, yeah.
So I'm curious, as you were exploring functional programming in Scala and thinking about what to bring to Kotlin, what are some of the things where you're like, oh, we got to bring this to Kotlin? And what are some things that you're like, oh, let's definitely not bring this to Kotlin?
That's a tricky question. So I remember very at the beginning of Arrow, one of the things that we played with were implicits, and they are very powerful in Scala. Sometimes I feel too powerful, because things like the cake pattern evolved from it, and I feel that the Scala community also has come back on a couple of those patterns. For example, the proposal that we once made with 47 for Kotlin was coherent type classes, which is like coherent implicits, which means there can only be a single instance. And that to me made a lot of sense. But the import-based implicits from Scala seem a bit tricky.
Yeah. So implicits turned out to be one of those things that was probably not a good fit in the world of Kotlin. As I was saying.
I mean, I don't think it's a good fit in Kotlin. So currently with the context receivers, they're always also going in a different direction. which I think is a very interesting one. So Kotlin prefers being explicit, where Scala oftentimes prefers to be implicit. So like implicit conversions and things like that. I don't think that would be a good idea for the Kotlin space. And personally, having some experience with both, I prefer to be more explicit, even if it requires a little bit more code. It's typically easier to understand and easier to follow for beginners.
Yeah, that's one of the maxims in the Zen of Python is explicit is better than implicit, and I've really started coming to understand that in recent years. Yeah, it is. It's when you're reading code, that's the thing. If it's doing something magical, you can't. I don't know. You don't. It's not obvious there. Then it's like, oh, I have to go chase this thing down. Whereas if it is,
right,
it just makes it much easier to understand the code.
There's such a balance with that. Like in Scala, there's pre-def, and then there's it's called, but it's kind of your default imports, and it's really nice to have default imports, but it is an implicit thing. What's fun is to, in a Scala codebase, turn off pre-def, and then you realize just how much is being brought in implicitly for you. It's one of those things where, like, I don't really want to have to import string, Scala, util string, whatever
or
it
the
is.
print, or all those things.
Yeah.
The things that everybody uses all the time.
Yeah.
So you're saying that there is no hard and fast rule.
Yeah.
You should or shouldn't do anything.
Yeah.
That's too hard.
Well, I think Kotlin.
What should be pre-def and what should be.
I think Kotlin takes an interesting approach there because a bunch of the imports from the standard library actually don't require imports. So, for example, if you're working with strings, with integers, with a bunch of the most common things, it doesn't require you to make an explicit import because the language, says, okay, this is a default. It's so common, you cannot override it, so you don't require the import.
Which, yeah, I mean, if it's something that I'm always going to use, I don't have to import it.
Right.
Then it becomes a waste. But how do we decide?
Right. Where do you decide where that line is? Yeah. That's tricky. So, what about higher order functions? I think that's one thing that is lacking in Kotlin, right?
You mean higher order kinds? Higher order types? Yeah.
Types.
Yeah. So originally I thought they were really missing, and we at some point also emulated them in Arrow, which turned out to be a big mistake because emulating them is horrible. If you have them, they should really be a language feature. But seeing how the things have evolved in Arrow, I don't really miss them anymore at all. So I feel that we can do all the same stuff without the higher kind of types. So I feel that we found a good solution for Kotlin, but I still think it's an interesting language feature. But at this point, I'm happy that they're not in Kotlin.
Okay. You would actually prefer that they're not.
There's some downsides to it. For example, in the collection APIs in Kotlin, oftentimes, for example, if you're mapping elements of a set, you will get back a list. And in some of these cases, it can be strange. This was actually not a great example because if I'm not mistaken, set doesn't have a functor because it's unordered.
I think so. I just ran into this recently with a set. I was calling flat map on the set, and in the flat map on the set, the function that you pass in has to return a list, and then what comes out of the flat map is a list. I was like, this is not a flat map, and I was so annoyed. But so yeah, I think that you can make it work just fine, but it's somebody who had an expectation of how a flat map should work on a set. It didn't work that way. It was annoying.
Right. So I think in the collection API, it's probably the only place that I've missed it in. But besides that, I don't miss it at all.
We were interviewing Richard Fell those things where you go, oh, I didn't know you could do that and still call it a functional language. But then I can see his argument. It's like maybe you don't need it.
I do miss not having curry in Kotlin. That's one of those features. I'm like,
you would like to have it.
Yeah, it would be so much nicer. I could do this so much nicer if I had curry.
Querying is something that I also don't miss in particular. But yeah, sometimes it's also taken to the extremes. And if you take things to the extremes, then it turns bad. So I've seen people that use querying because they want to pass everything as a value to a lambda per se. And using explicit lambdas everywhere in Kotlin also has benefits. For example, with the inline support, where you can use suspend inside of an inline lambda is really powerful. But that kind of stuff doesn't work if you pass a lambda as a value.
Yeah, I have to say I've been real impressed with their design choices. Just, they're very pragmatic, I feel like, in Kotlin. And that's been very satisfying. But I've also been starting to see some of the things that are in Scala that Kotlin doesn't have, and I'm kind of going, maybe it would be nice to have some of these things. Like you had to create the equivalent of a for comprehension in Arrow, right?
Originally we did, but we actually found a solution for that as well, so we don't need it anymore. And the current solution that we have actually works really well. It just uses suspend and inlining, and you don't need comprehensions anymore. You actually don't need map and flat map anymore. It's just function application all the way through. No magic at all.
Yesterday, the binds we're doing the ether.
Yes.
Yeah. And with Arrow 2, and you can actually already do it today, but with context receivers especially, you don't even need bind anymore. So if you put the effect in the context receiver, or you can do it today also as the receiver of an extension function, you get the syntax available inside of the method body. And then, for example, if you have suspend, you can call, let's say, raise or shift to raise a logical error instead of creating an either left and binding it. And since it's suspend, you can call it in the map of a list because the map of a list is inline. So all of these things naturally compose without having for comprehensions, without having monad transformers, without requiring any of that stuff. So it really decreases the learning curve for all of these patterns.
So you're using suspend. You're basically hacking suspend as a short-circuiting mechanism to say, okay, we're not going to do anything on this anymore. We'll just suspend it, and you never resume.
That was one of the original implementations, but it's actually gone a bit simpler. We're basically just using like a control throwable, which is backed by the cancellation exception, so it can cooperate with the coroutines, and it doesn't have a stack trace, so it doesn't imply any performance penalties.
Okay, so you're using the coroutine structure and the termination that's in there. Okay. So that way you could just say, okay, this is all set up. It's using structured concurrency, so I'm safe in terms of resource cleanup and everything.
Yes, exactly.
I realize we've kind of dove into Arrow without talking about what it is at all. Can you give us? You're probably used to giving the high-level overview to what Arrow is. So can you give us that?
So very, very high level, Arrow is actually an open source organization that aims to build idiomatic and type-safe programs in Kotlin. So it has a bunch of different libraries that aims to offer, elegant solutions with a low learning curve for writing functional patterns in Kotlin. And then I would say the most popular library right now is probably Arrow Core, which offers these things that we were just discussing like either and these DSLs that give you typed errors in Kotlin.
But then there's a number of other libraries that presumably use or built on top of Arrow Cover.
Yeah, so Arrow Core is what really complements the standard library, right? So it has a couple of things. It's a quite small library that adds a couple of things that we feel as functional programmers is missing from the standard library. Then we have ArrowFX coroutines, which similarly complements the Kotlin coroutines library with a couple of higher level operators like racing, resource management, parallel operations, a bunch of extensions on Kotlin flow that we're familiar with from FS2 in Scala, for example. There's Arrow Optics that offers a DSL for working with immutable data. So it's like the copy method on steroids. So those are the three most popular modules or libraries, I would say, right now.
So, and how would you, I don't know how much you have looked at Zio, but how would, if you have, how would you compare the two?
So yeah, compared to Scala is tricky. I would say that Zio offers similar functionality, but I would say the biggest difference is where Zio offers everything in an Uber monad, so everything is single type. Arrow aims to offer things separately but composable. So like I mentioned before, everything composes naturally in Kotlin. So the goal of Arrow is to basically offer you things that you can pick and choose what you need when you need it. And similarly, when a beginner comes to the language or comes to Arrow, he can only learn a small part, get started with that, and then build upon and expand his knowledge over time and start using more features whenever he needs them.
And I mean, I know one of the main things that Zio goals of Zio is to allow the programmer to program at a higher level without having to think about a lot of the details that we have historically had to work with, especially when dealing with concurrency. Like you could just say what you want and not worry about tuning or resource management or any of those, safety. And is that the kind of experience that you're able to achieve with Arrow as well?
Yeah, so I would say also a big difference with Kotlin and Scala is that Kotlin doesn't have any of the concurrency constructs in the standard library. It only has future, which maybe is a legacy thing in Scala. Kotlin has a very nice approach with that. They have Kotlin coroutines outside of the standard library. And what we actually did in ArrowFX coroutines is we built this resource type, which again, you can use as a wrapper or in the context receivers. And it offers you these same powers on top of structured concurrencies with the same principles as structured concurrency. So it offers you a solution for resource management, for example, that works same as coroutine scope, but for resources in a very elegant way using suspend. And like I said, it composes with typed errors. So for example, if you have a typed error that happens while you're using a resource, it will also clean up the resource, but you can pick and choose what you want when you need it.
Yeah, you responded with an example of my racing to concurrent HTTP requests, and it was a pretty concise syntax for being able to handle the resources, the cleanup, pool allocation, like all these things that traditionally can get pretty messy and likely the user will do it wrong. And it definitely was a good example of how Arrow can take up a complex problem like that and make it apply a pretty simple solution to that problem. So
that's a good question, or that brings up the question that comes from that experiment that you're doing, because you did the experiment with Zio and you said, okay, we'll race these two things, and the one that didn't win was automatically immediately terminated. And then you got an example with Loom, Project Loom in Java, and you discovered that that wasn't the case. Now, maybe they'll fix it, but it's hard to know with Java. So in that case, like, does Arrow, let's say, do it the right way, immediately terminate?
Yeah, so I would say Arrow does it the right way, and so same as what you would be used to from type level or CO. I've also looked into this with Loom, and what I remember from it is that Loom has a problem that you can not make something uncancelable, right? So, and that is a problem with the finalizers for the resource management. You cannot say, okay, this thread has to run no matter what to run the finalizer.
And does that seem like an inherent problem, or is that something that they could fix?
Seeing that Loom happens mostly with a bunch of magic in the hotspot, it seems like something that they can fix. But I'm not familiar enough with the low-level implementation of Loom to really make a comment on that.
One of the things that I've been thinking about is something that John DeGoes said a while ago about Zio, is that he, initially when he started working on Zio, he was trying to do things in a very Haskell-oriented way in Scala, and he kept hitting barriers like, oh, the language doesn't allow me to do this way and this way. And so I think one of the big breakthroughs with Zio was that he said, we're just going to embrace Scala as it is and not try to make Scala into Haskell. And that, I think, led to a really nice experience in Zio. And I think that Arrow has had that same journey. I think initially Arrow was trying to do things in, I don't know if it was Haskell or Scala or both way, but the initial experiments around the do notation or for comprehension, whatever, in Arrow was, I think, trying to adopt the way that Haskell and Scala were doing sequential monad operations. And instead, you just said, well, this doesn't feel quite right, and so let's figure out a way to do this within the constructs of the language as it is. And you got to the suspend functions, and it's very ergonomic, feels right. Context receivers will get even better. So I don't know. Is that accurate to describe kind of the journey with Arrow?
Yeah, that's very accurate. But actually, a lot of things happen. So maybe to provide some more background, next year Arrow will actually be 10 years old. So the first commit in the library is for 2013. And originally there were actually two projects. There was a project called Functionale, which was by Mario, which was an ex-Scala developer. He was one of the early people in Scala that were doing Spring in Scala, but that didn't really work well, so he switched to Kotlin. Spring and Kotlin go really well together. But then, again, he was also missing a bunch of things from the Kotlin standard library, like either, try. And he built a library around that. And then in 2016, or early 2017, the Arrow library, back then called Category, was founded in the Spanish community. And these were people basically trying to learn functional programming from Scala type level, but in Kotlin. So a similar journey that I took. And I was on a similar path.
The category theory, like type class hierarchy, and trying to get the same thing in Kotlin. That's why it was called category.
And I was at the time on a similar path. So I was trying to figure out what optics were. And I was interested in a library in Scala called Monocle. And I decided to, I'm just going to build Monocle in Kotlin to understand what the problem and the solution of this, paradigm or pattern is. And then Raul reached out to me and he said, hey, do you want to join our organization with your library? I think it would be a good fit. And I joined him. And a little bit later, we reached out to the maintainers of Functionale and said, hey, do you want to come together and let's make this new open source organization called Arrow? Let's just all work together instead of making this divided community of functional programmers. That's how Arrow got started. And so we had a lot of the things that you mentioned, the type classes, the higher kind of types. We were emulating implicits in the beginning. It was all kind of weird in
So
Kotlin.
trying to re-implement the way that it is done in Scala into Kotlin.
Exactly.
Very similar to how Steve was trying to implement things the way they've done it in Haskell and Scala.
And at the time, there was also no Kotlin coroutines. So we built an IO data type. And by the time the IO data type became public, it was around the same time that Kotlin coroutines was released. So after 1 year figuring out what we were going to do in that space, we decided, okay, let's ditch whatever we have and let's embrace the language. But there is a very long learning journey behind what Arrow is today.
Yeah, it seems like where you're at today, you're not fighting the language and its constraints. You're working with them, and I think that does lead to a much better experience.
Yeah, I can't remember any situation where somebody was going in and saying, "Oh, let's make this language something else that has been successful." And I think part of it has got to be just the mental model for the programmer. Because you go, okay, I know this language, and they go, well, no, do this instead. And it's too big of a shift. It's confusing.
Right. I mean, I think people typically come to a language because they see things in the language that they like. So if you fight the language, then, it's going to confuse most of the developers in that language.
So what learning resources are there that can bring people in, especially people who maybe don't understand functional programming, that can bring them into Arrow?
So there's a couple of books. Hard to think on the top of my mind. My colleague Alejandro Serrano recently wrote a new book on functional programming in Kotlin. But I would say the Arrow documentation is also quite nice. We put a lot of effort in it, and especially for the 2.0 series, it's gonna again receive a lot of love. So from the people behind Arrow, we really want the Arrow website and documentation to be everything that a beginner needs to get started with Arrow and functional programming in Kotlin. So we don't want to hide it behind a paywall in a book. They should find it right there on the page.
47 Degrees also has some good video trainings around Arrow.
Yeah. So from 47, we also have a paid course that you can follow. And I've also been on the JetBrains YouTube with Anton talking about Arrow on the back end. So there's a lot of resources all over. Next week, I'm also giving a talk on Kotlin Dev Day about resource management and graceful shutdown. So that will be a public video soon. So we're heavily pushing a lot of content in all directions.
It does seem like the learning curve for functional in general and some of these libraries in particular is an obstacle for bringing people in.
Yeah. So, well, I would say that was one of my biggest goals for the 2.0 series, is to really lower the learning curve. I mentioned it very briefly before, but there's no more need for map and flat map. So everything just works based on DSLs. And it gives you, depending on what you want, it gives you maybe 2 or 3 functions. For example, if you're working with type errors, there's only a single function, which is raise, that you can use to raise an error. And then there's 2 error handlers, recover and catch, depending if you're working over a typed error or a throwable. So, that basically replaces the entirety of the monad hierarchy and the monad error hierarchy with 3 functions. So I would say that drastically decreases the learning curve. In the either type, I merged the PR this week I think it decreases the API surface from something like 50 or 70 functions to 15 functions. So decreasing that learning curve is a big priority for us.
Okay, so you might even be able to achieve making this somebody's first functional programming experience, rather than having to go through all the different things that we have.
Yeah, I hope so.
Challenges with learning functional programming is that oftentimes journey that people have to go on is, well, to do anything useful, you got to learn what a monad is, and that becomes an obstacle that is challenging.
You mean a burrito?
A burrito, that's right. Yeah. Whereas the approach that you're moving towards is saying, like, yeah, if you need a monad, you can have a monad, but you can do a lot of useful functional programming stuff without a monad, or maybe it is a monad underneath the covers and you don't really care.
Well, if you can hide it well enough, then you don't have to explain the idea behind it.
Wow, that's very close.
So you mentioned Arrow 2. What version did we try yesterday?
Oh, I'm sure it was 2.
Is 2 the latest production?
No, so I'm sure you used 1.1, which 1.1.3 is the current latest version. Arrow 2 is in not heavy development, it's in development. Most of the stuff that we currently still want to work on is documentation, because we want to orient the documentation around what I just said. We want to get rid of everything that mentions monad and these difficult concepts. We want to simplify the website to be an easy entry point for people to learn what is functional programming in Kotlin. So we don't even want to talk about monads or either. We just want to have a page like, do you want to work with typed errors, right? Then this is how you can do it, and it's probably going to be a single page. Do you need to recover from errors? Do you need resilience in your server? So we're going to try oriented about use cases. There's going to be the API docs, of course.
Okay.
But
so a big part of Arrow 2 is to kind of reduce the surface area, reduce the ties to category theory, which is interesting. That part of Arrow kind of started as a category theory implementation, and now you're like, let's not make people have to learn category theory to use this.
Right. I don't think everybody needs to understand category theory to be a functional programmer. It might be appealing and interesting to some of them, but it's definitely not a necessity.
When you throw that at beginners, it just puts them off.
Yeah, exactly.
All this stuff.
Yeah, it's not a nice thing to face. You're an absolute beginner, so we're really trying to orient it around that. But to come back to your original question, I think the timeline for Arrow 2 is going to align somewhat with Kotlin Conf. So I think the first quarter of next year is when the 2 series will be public.
And is it possible to see previews at this point?
Yeah, so everything is happening in the open. So there's an Arrow 2 range. There's a 2.0 label on GitHub. You can find all the closed PRs. And a big priority was also to have all the design decisions documented in all the PRs. So if you look up one of the PRs, you will see a large document finding why did we do what. So that is visible and it's in the Git history and everybody can find it.
Okay, I think because we were using Arrow 1, we didn't see a lot of the things that we're talking about here. Yeah, and that sounds pretty. Now I'm really intrigued. Yeah, this is going to be a big step forward for helping people get into functional programming. Jeremy would be yes. I was just thinking that very thing. FP through Arrow 2. Exactly. Yeah, I because I know a little bit about functional programming, I'm definitely not an expert. I'm like, I get all excited when something's an implicative or whatever. And
And so I like that piece, but I also realize that most people, they don't want to hear the word applicative or think about applicative.
Yeah, my brain just froze up when you said that.
Exactly. And so I think that's been the biggest challenge for functional programming is figure out how to take these very powerful constructs and make them non-offensive and relatable.
Well, and I think our big shift in the last couple of weeks was looking at Zio and saying, oh, well, here are its capabilities. Do you want those capabilities? And then it's like, oh, well, yes, I often do. And here's, you can do, like, if you want to race two things together, you just say that, and it works, and you don't have to worry about all the things. I guess one of the things I'm a little stuck on is functional programming isn't about concurrency, and yet it's so useful. It solves so many problems in concurrency that the two are often conflated. And so that makes it, that makes it harder to, I guess, explain, and yet it's a strong motivation.
Right.
Because you could go, okay, all the problems that concurrency has. Well, if you take this approach, you don't have to think about most or all of them. Then people can go, oh, okay. But there's a whole bunch of other stuff in there. It's like, okay, everything's going to be safer, et cetera, which we need for creating reliable concurrent programs. But it's not essentially what it's about. So it's like,
Right. Yeah, I think what functional programming, does very well is it always tries to hide a lot of complexity. And what it does very well in concurrency is that it takes a very principled approach. So you can always be sure that, things compose, and when they do it correctly. They hide most of the things are hidden away that you don't have to think about, all the low-level concurrency stuff that we typically deal with. So it brings concurrent programming to a much higher level than that we're used to from Java, for example. That is also exactly what we're trying to do with arrow-fixed coroutines. It brings this higher level operations that we know from functional programming type level, CDIO, Haskell. It brings them on top of Kotlin coroutines. Like, for example, Kotlin coroutines doesn't have a simple race operator where you can just put two suspend functions, and if one wins, it cancels the other. Need back pressures on finalizers and whatnot. Kotlin doesn't do that out of a box, but arrowfix offers a simple race function that cooperates with whatever Kotlin code you already have. And if everyone, and that's also one of the things with Arrow, if Kotlin at one point decides, okay, we are interested in having this operator, we're happy to move it, we're happy to contribute it and remove it from our library. Like I said, the libraries want to complement Kotlin, not fight against it. So I think that is one of the things that functional programming does really well. There's let's say a side effect to it is that, for example, if you're working with I/O, and that is the problem that CO solves, if you're working with I/O and you also want to work with either, you very quickly fall into the pit of monad transformers, which is a very difficult topic, especially for beginners. And there are problems that Zio and Arrow try to solve.
Yep. One of the things that it's all kind of becoming understood for me now, is so many of the concurrency libraries that I've looked at over the years, you very quickly drop into, well, you want to make sure that you allocate the right number of processors for your problem, and you almost immediately get into the tweaking of the implementation, and it's like, it just gets so messy so fast, and then when you hit the right level of abstraction, it's like, don't worry about that. We're taking care of all that for you. You can probably still go in and tweak it if you want to, but almost virtually never would have to. And it's just like, okay, that's what I want.
Right.
Yeah, functional programming is the first time that I've seen working with concurrency have high level useful things like races and that sort of stuff. But then also do the right thing most of the time by default. And like fiber scheduling is one of those examples. First fibers and then fiber scheduling is an example of it can do things the right way by default. Generally, sure. There's some cases where the default fiber scheduler is not optimized for a particular problem, but for most use cases, it's good enough.
Well, and one of the things that ZO2 added was a better scheduler. We were just reading about this. And one of the things it can do is, instead of being fixed, it can dynamically adapt its scheduling mechanism to optimize your program without you having to think about it. I don't know if you're familiar with that, but are you looking at that for what you're doing, or are you just saying, okay, the Kotlin X coroutine scheduler we're just going to work with that?
Well, we have not looked at implementing our own schedulers, but I know Kotlin X has a quite advanced dispatcher that does a lot of these things already out of the box as well. So they already support a lot of these things, and that's great for Arrow because that way we don't have to. But I also know it's quite easy to implement your own schedulers through Kotlin X if you want to. But so far, we've never had the need to do so because, coroutines in Kotlin are so efficient. They work thanks to the compiler. They have such optimized Java code that, whatever schedulers and dispatchers they already have, or they just work perfectly out of the box.
Well, that's good to hear, because obviously you don't want to have to write your own scheduler. You don't have to. It's very specialized.
Yeah. So, is Arrow 2 when you'll start taking advantage of context receivers?
So, sadly, Kotlin context receivers will probably not be stable for quite some time. I wish they would become stable sooner. What we're actually we're, let's say, optimizing for DSLs. So we've really invested a lot more thought in how can we design our DSLs that we currently have, like the either block with the bind. How can we design them in a better way? For example, currently we have eager effect scope, which works with non-suspending code, and effect scope, which works with a suspending code. We were able to merge those two types together in a single type, which is now called race. And we've really invested a lot of thought into optimizing these DSLs. So we actually don't really have the need to optimize for context receivers in the library. Whenever they become available, you will be able to take full advantage of them with whatever we've done already in the 2.0 series.
That's cool. Maybe we should hop back for a minute. Could you explain context receivers a little bit?
Okay, so context receivers will give you the ability to put multiple extension types on a function, basically. So currently we can define an extension function on a type, and then you can add a method, like it looks like an instant method on that type. And then inside of the function body, you have access to everything from that type, from the public API. But since that is in the receiver, an extension function is only limited to a single type. When you put it in the context, you can have any amount of types that you want there. And that is very interesting because you can use it to replace dependency injection. You can say, okay, I have this function and it depends on, let's say, my database and this network interface. And then when you want to call that function, you need to make sure that those things are available. And then only then you can call the function in a type-safe way. And for example, with the race type that we've been discussing about, let's say you have two different error types that you want to be working with. You can put both of them in the context receiver, and then you can handle one or the other whenever you want to. So it's similar. This concept is known as capabilities in functional programming. Scala has it as well, with context functions. And it basically restricts a function to say, okay, you have these types in the context receiver. So if you want to call these function, then these things have to be available.
When I first was looking at context receivers, I'm like, oh, this feels so close to type classes. And as you know, I tried to push context receivers to be type classes, and you and Raul kind of backed me off that ledge, thankfully. But I don't know, it's still like it does feel like it's solving a similar problem as type classes, but
it's similar to constraint-based programming. Like for example, in Haskell, a lot of type classes you will actually use to put a constraint on the function to say, okay, I have this type A, and it needs to have an instance of numeric, for example, or I have this type A and it needs to implement this server's type. So it solves the problem of constraint type programming. What it does not do is do the
is to constrain
exactly.
constrain the calling of a function to require some context.
Yeah.
Some external context.
Yeah. So it solves the problem of ad hoc polymorphism. What it does not solve is the injection piece or the implicit from Scala. It requires you to make it concrete at some point explicitly.
Yeah, and I guess that's the difference with how type classes work, at least in Scala, is that you can then have implicits drive that context that's needed. And
so you can.
There is no implicit,
So in Scala, you can say, okay, if you want an instance for this type class, you need to have an implicit for this nested type class. And that solves the problem of generic derivation in a lot of cases. Like, for example, a problem you were trying to solve with JSON encoders. But that's the piece that does not exist in Kotlin because you still have to explicitly wire all the pieces together.
Yeah. So, did you just go directly to functional programming, or did you start out in, I don't know, OO, or, I mean, what was your path to get where you are?
So like I said, I was originally a Java Android developer, and I was heavily invested on OP at the time. I was super into all the OP design patterns. I was applying them everywhere. I was, very into TDD and everything, all the common patterns you would expect from an OP developer.
You have to use them everywhere.
Yeah. And then ReactiveX became very popular on Android, and it was completely new to me. So like most of the things I do, I took a deep dive. I went all in because I wanted to figure out, what is exciting people. What are people so excited about? And then I really fell in love because it gave me this first taste of an effect system. Java comes very close to a functional effect system. And I really loved it. And at first I started applying it in OP in Java. And then step by step, I started learning new concepts and applying them. I went to Kotlin and I had, data classes with sealed classes. So I started with ADTs. I started using ADTs in my RxJava observables, and step by step that evolved into what I'm doing today.
Yeah, it's interesting that I guess we had the same journey or on the same journey from object-oriented to functional. It's hard for me to go back.
Oh, well, yeah, once you start seeing I guess I'm seeing it, because, I mean, my beginnings were in objects, and, whoever created this knew it. They were going, yeah, we really understand this. Now I can go back and look at it and go, oh, I see the flawed thinking in the steps. And at the time it was experimental. It was like, okay, we've been having this problem. This encapsulation seems like that should solve that problem. And it's like, yeah, it did seem like it should. But then over time, we started seeing, oh yeah, this was this was a flawed step, and making Java like Smalltalk was because, Smalltalk was a very different language. It was inherently dynamic, and just saying, okay, well, we'll model it after Smalltalk, but we'll make it static. No, that was a flawed thought process. So but boy, it's just, I guess in the end, I now see the whole field as an evolutionary process, and now we're trying to figure out, well, what's the best way to express functional, and the kind of stuff that you're doing, especially working on making it simpler. I find that very inspiring.
So you've done a lot of UI programming, mostly Android, it sounds like.
Yeah.
One of the places where I think functional is not kind of had a big impact yet is on UI programming. And I don't know if you've worked with Elm. Have you ever played with Elm?
I've looked at it, but I've not really worked with it.
For me, Elm was one of those moments where I'm like, oh, I would so much rather build UIs in this way with a functional foundation than with like mutable state and callbacks and the typical
Right.
way that we used to build UIs.
The Wild West of JavaScript.
So many UI frameworks.
Well, it's true.
But I must say, I think I've not worked on Android for quite some time, but I can see that in the UI space or the front end space, a lot of things are evolving also towards a more functional trend. Jetpack Compose is, in my opinion, a bit of functional programming in disguise as well. So stream-based UIs is a pattern that works very well with Compose, from what I've seen. Similar with React.
You mean like treating the user input as a stream of events?
Yeah, so what I used to do back in the day with Java, so I treated the user inputs as a stream, and then basically, I composed those streams, and then that triggered some actions, and then that resulted in a stream that basically at the end, the stream was just rendering the screen. That was all I was doing. So I was collecting the inputs as separate streams and converting that into my business logic, and that resulted in a single stream, which was my UI data model. And then every time I got a new event of the UI data model, I was just, rendering it on the screen. And with Jetpack Compose, that pattern became, I think, a lot simpler even, and even more powerful.
Yeah, I think there's stream-oriented UI is a good way to look at one of the ways to help UI programming move towards functional approaches. Just because streams are, I think, hard in programming. Callbacks and stuff. Orchestrate things across callbacks.
Well, and also in Elm, it allowed them to do the time traveling debugger because you simply capture all the events, and then you can just back up. And the purity, the functional purity allows that. So that's really impressive. And again, you have this, do you want this capability? Well, yes. Well, here's the foundation that you need to allow that.
So you've been doing Arrow mostly with backends, but I would imagine that there's quite a few people using Arrow on Android.
Yeah, when I get started with Arrow, I was also using it on Android, but I think most of the current Arrow users are actually using it on Android. So a lot of our user base are on Android. But what's also kind of funny is I think the server side, things of Kotlin is a very quiet space. A lot of companies don't want to publicly share that they're doing Kotlin on the server side yet. I know there's a bunch of them using Arrow on the back end, but they're not, shouting it from the rooftops. So we don't really know. We can see the downloads are increasing a lot every year. So we know that there's a lot of new users, but we don't really know where they're coming from.
Well, it seems like people I know are more and more, especially Java programmers, are more and more attracted to Kotlin. And so it seems like at some point, those companies are going to start advertising that they're using Kotlin just to bring programmers.
I hope so, because it's a great. Sorry, I really hope so, because it's a great language on the back end. I really enjoy using it on the server.
Yeah, a lot of companies still advertise for Java developers, but then they're actually using Kotlin. I figure that they can onboard Java developers to Kotlin pretty easily.
I mean, it's hard to find an experienced Kotlin server-side developer. It's almost easier to look for a Java developer that's interested in learning Kotlin. And arguably, it's not hard to train an experienced Java developer to write Kotlin code. It's a small investment to make that I think pays off pretty quickly.
Do you have a sense of what people are usually using in terms of server frameworks with Arrow on the server, like Ktor or Spring, or like?
So I think
Spring and Arrow together.
Spring still dominates a big chunk of the space. I've personally, I know a lot of people that use Spring with Arrow. Yeah, but I personally really like Ktor. It just fits in really well with the language. I've recently also been playing with Ktor, targeting Kotlin native, which works really well. There's Kotlin for Ktor on the serverless side of things. So the ecosystem is pretty cool, and it's evolving pretty rapidly, I would say.
Arrow publishing multi-platform, so you can do Arrow, Ktor, all with Kotlin native.
Yes. So I have a project on my GitHub. It's using Ktor, Arrow, code tests for testing. It's using actually SQLite with an experimental Postgres driver for Kotlin native, which is really cool. So I get most of the tools that I would use for building a GVM backend, but I get them right there on native. The binary is insanely small. The build times are super fast. The startup is almost instant. So it's pretty cool.
Nice. All right. Well, anything else?
No, my brain is full.
Yeah. Well, Simon, thank you so much, and looking forward to Arrow 2, and hopefully that's the moment when we can get people in functional programming.
Mm-hmm. Yeah, I'm really intrigued now to see how that's going to come out.
We'll write a effect-oriented programming version in Arrow 2. Sure.
That's awesome. Thanks so much for having me. It was great being here.